Today's lesson centers on experimental and theoretical probability. Theoretical probability is what should happen. So in a perfect world, what should happen? So if I'm flipping a coin, I should get heads 1 out of every 2 times, or 50% of the time. Experimental probability is what actually happened when an experiment is performed. So if you're flipping a coin and you flip it 10 times and you get heads 3 times, tails 7 times, your experimental probability of getting a heads was 3 out of 10, or 30%. Let's take a look at a couple of examples. The bar graph shows the results of rolling a number cube 50 times, same thing as rolling a die. What is the experimental probability of rolling an odd number? Okay, so this is an experiment that was actually performed and they recorded their results here. So if we look at the odd numbers, 1, 3, 5, we'll see that there's 10 ones plus 8 threes plus 11 fives for a total of 29. There were 50 rolls, so the experimental probability of rolling an odd number is 29 out of 50, or 58%. Remember, you can get that percentage by taking 29 divided by 50 and then multiplying by 100, or you see that 50 times 2 is 100, so 29 times 2 is 58. We're going to leave our answers as a fraction unless asked otherwise. So it rains 2 out of the last 12 days of March. If this trend continues, how many rainy days could you expect in April? Okay, well, first of all, we know 2 out of 12, it reduces to 1 over 6. It's always best to reduce so you're working with smaller numbers. It makes it a little bit easier. So we'd expect 1/6 of the days in April for it to rain. Well, there are 30 days in April, so we're going to multiply this by 30. 1/6 of 30 gives us 5 days. So there are 5 days in the month of April where we would expect it to rain, according to how much it rained in March. Going back to experimental probability and the experimental probability of rolling a 1. Okay, our experimental probability up there at the top in our chart was 10 out of 50. It looks like these questions are a little bit out of order and I'm not quite sure why, but our experimental probability then is 1 in 5, or 20%. Let's take a look at a couple more examples. Each letter in the word theoretical is written on a separate slip of paper and placed in a hat. A letter is then chosen at random from the hat. What is the probability that the letter chosen is an E? Well, the first thing we need to do is to count the letters in theoretical. I have 11. How many E's are in theoretical? Count 1, 2. So the theoretical probability of me pulling an E out of the hat would be 2 out of 11. What is the probability that the letter chosen is a vowel, either A, E, I, O, or U? So we have 1, 2, 3, 4, 5. There are 5 vowels out of the total 11. What is the probability of choosing a T? We have 1, 2 T's, so it would be 2 out of 11. The same probability that it is to pull out the letter E. Let's now compare experimental and theoretical probability. So you did this in your coin toss. You performed an experiment, and you compared that experimental probability to what we theoretically should have gotten, which would be 50% red, 50% yellow. Now, The bar graph here shows the results of rolling a number cube 300 times. So not 50 times, 300 times. So they've performed the experiment more times. So what is the experimental probability of rolling an odd number? Okay, so again, our odd numbers are 1, 3, 5. So 48 plus 50 plus 49. Okay, that's going to give us 147 out of 300 times. Now this one's a little bit tricky because we have to always reduce. Now remember, if you were to put this into your calculator, it would reduce for you, okay, as this is a really tricky one to do. Here you could reduce by 3, so you would get 49 out of 100, which would be 49% of the time. So how does the experimental probability compare with the theoretical probability of rolling an odd number? Well, theoretically, okay, there are 3 odd numbers out of 6 total. So there's 1/2 there, which is 50%. Okay. Our experimental probability was 49 out of 100, which is 49%. Okay, so they're very close here. Our experimental probability is just 1% less. Now let's compare the experimental probability in this example, which was 49%, to example A on the front page of your notes. Example A, we got 58%. Which one is closer to the theoretical probability of 50%? Hopefully you answered the 49%, where this is where we did 300 trials. We did 300 trials here. In the first example, we only did 50 trials. So what I'm wanting you to see at this point here is the more trials that you perform, the more experiments that you perform, okay, the closer you get to the theoretical probability. So you might want to pause it here and just take a second to write down the key takeaway from this piece of the lesson. The more trials you perform, the closer the experimental probability is to the theoretical probability.